Hello, and welcome again to my Physical Science online video lecture supplement series. Today's video is actually for the lab class, so I wanted to do a sort of post-quiz walkthrough. So this is the post-quiz video for the Blender lab. So the quiz that covers our Blender lab. And to do this, what I have done is I've done an analysis of the questions on this quiz. So let's pull that up. So this thing says that on average people are spending 32 minutes doing the quiz. Looks like the average score on this quiz was an 86, so I guess good work, guys. That's kind of a A- in this class. And I guess that makes sense. I mean, there's 6 easy questions and 5 medium difficulty less questions on there. And I guess the analytics says that it really likes the questions I've written. 6 good ones, 3 fair ones, 2 that it couldn't figure out what to do with, and no poor questions, no hard questions. Well, that's fine and good unless you happen to be that one student who found the whole quiz to be unusually hard. In any case, what I've done here is I've ranked these questions in order from most difficult to least difficult. So if it says 100%, that means that everybody who attempted this question got it right. If it says 0%, it would mean that nobody who attempted the question got it right. And so I'm not going to do every single one of these questions. In fact, I'm not even necessarily going to do the 3 hardest questions. Instead, I just wanted to do a few of the questions that I've specifically been asked about on this quiz. So let's look at some of these more difficult ones, and then also a few people have specifically asked me about this question that apparently just under 2/3 of the class got right and just over 1/3 of the class got wrong. So these first 2 questions, I guess, were questions 9 and 10 off of this quiz. So these 2 questions were sort of like almost like part A and part B. The main questions here was how much heat did you add, and therefore what is the power of the blender. So in order to answer number 10, you basically needed to do number 9. So for number 10, the power is basically going to be the amount of heat that you added divided by the amount of time that this process took. So in order to get the answer to power, you need to get the answer to heat. And so on this quiz, I basically really wanted to know what the experimental value of the power is, but I went ahead and broke that up into 2 steps for you so that you would not have to do all of the equations at once, because suddenly you're having to juggle 2 equations, and that's really difficult to do for some of you guys. So how much heat was added? That's what number 9 is asking. So that how much heat is added, I put as a delta H. Basically, what you use is the equation that the heat added to an object is the mass of the object times the specific heat capacity times the change in the object's temperature. So what is the object in this case? Well, it is 0.5 kilograms of water. So we have 0.5 kilograms, and then that needs to be times whatever the specific heat capacity of water is, and then the initial temperature is 20 degrees C, the final is 25, so we could maybe put 25 degrees C minus 20 degrees C. And all we need to do here is just get this specific heat capacity for water. So one place that you can get that specific heat capacity for water is to go look it up in your textbook. You could also, of course, go Google the answer. In any case, the instructions to the lab did kind of hint that you would need that specific heat capacity for water. In any case, you go look up what the specific heat capacity for water is. As an alternative to looking it up in the text, you could find it, let's see, can you find it somewhere in the handout that told you what to do for the lab? Okay, so here's our heat equation. Oh, hey look, specific heat capacity for water is this. Okay, so you don't even really have to go to the textbook to look it up. You can look it up in the handout. And I think most of you did that because it seems like that particular question most people did well on according to the analytics. In any case, the answer for the specific heat capacity for water, 4,184 joules per kilogram Kelvin. So let's put that guy in here. We don't have very many significant figures, so I'll just put 4,180 joules per kilogram degree C. Alright, so now all of our units have matched. So out comes the calculator. We have 0.5 kilograms. We're multiplying that by this number. And that's times the difference between 25 and 20. So 25 minus 20, close parentheses, in case you needed to know how to do that. It says 10,460. So this amount of heat that has been put in, or in your handout it would have been a delta Q. Doesn't really matter what you use. It's 10,460 joules. So that answers question number 9. Okay, question number 10 says that we want to know how much power and that this is delivered over 20 seconds. So we take 10,460 joules and we divide it by 20 seconds. And so what that gives us is, let's go ahead and divide this by 20, 523. So the experimental power of this is 523. A joule per second is the same thing as a watt. So this is the answer then to number 10. So that's that then. So these were the two most commonly missed questions on this exam. So I'm actually going to go ahead and skip this one about running the blender for a longer amount of time because I wanted to answer this fourth most frequently missed question, specifically because I actually received a couple emails asking about it, and so I'm going to go ahead and answer that here, and that way everybody who's wanting to know what's the real answer to it has the answer. Interestingly enough, I also asked on here what's the specific heat capacity of water in joules per kilogram degree C and what is it in calories. So just about everybody got it in joules per kilogram degree C. In fact, it looks like only one person missed that question, which I guess is good news because the answer was, of course, right there in the handout. And as I mentioned earlier, about a third of the people missed this same question in terms of calories per gram degree C. Again, to get the answer to that question, you might go look up what your textbook says. I'm assuming that everybody has some edition of this Shipman, Wilson, Higgins, and Torres physical science class, since most of you are actually in my lecture as well, and this is required for that. And if you're not in my lecture, you're almost certainly in Dr. Menon's lecture. He also requires this textbook, so presumably all of you have this textbook. So let's see, what does the textbook tell us? Basically, you have to look at table 5.1 in that textbook, which is labeled specific heats of some common substances. And what you come up with is that for water, it is 1 kilocalorie per kilogram degree C. So we have C sub P equals 1 kilocalorie per kilogram degree C. Well, the question's asking though, what is it in calories per gram degree C? So we've got to convert this kilocalories into calories, and we've got to convert this kilograms into grams. So kilo means 1,000, so 1 kilocalorie is equal to 1,000 calories. 1 kilogram is equal to 1,000 grams. Alright, so if we want to get the answer from kilocalories per kilogram degree C into into calories per gram degree C, we've got to do some multiplying. So we basically have C sub P is equal to 1, and I'll just write it like this, kilocalorie over kilogram degree C. So now we got to get rid of that kilocalories, so we put up here 1,000 calories. We divide it by 1 kilocalorie. Okay, that gets rid of the kilocalories. Now we got to get rid of the kilograms. So to do that, we have 1 kilogram up here, and that is equal to 1,000 grams down here. I guess you might want your calculator in order to do this. Let's see here. We have 1 times 1,000 times 1, so that takes care of the top, divided by 1 divided by 1,000. Looks like the answer is 1. So our specific heat capacity for water is 1 calorie per gram degree Celsius. And that's the answer to this fourth hardest question on your quiz. And I think that's all I'm going to say about this particular quiz. I don't want to go solving every single question on the quiz for you guys. But thanks for watching, and hopefully this answers the bulk of people's questions about this particular quiz. So I hope this was a helpful video to you all.